Hello everyone, my name is Ahmed Koutbia. Today I would like to share with you a video on how to create and launch an instance or a virtual machine using OpenStack Mitaka, which was released in April 2016. So we will start our presentation with a case study. So let us imagine that our manager, Mr. Ghafwan, is considering to implement a private cloud in our organization. He heard lots of good stories about OpenStack, and he asked us to do the following proof of concept. So first, we want to create a virtual machine or an instance using the latest OpenStack stable release, which is Mitaka in our case. Second, we would like to create a VM or an instance which has the following configuration. In terms of the number of CPUs, it would have one CPU. RAM, it will have 1 gig. The permanent disk space, it will be one gig. And then for the OS, it will be running Cyros. Cyros is a minimal Linux distribution designed for testing purposes in cloud environments. And in terms of the network configuration, the VM should have an IP address in the 10.0.1.0/24 network, and it should also be accessible from our company's public network, which is, in our case, 192.168.1.0/24. So to be able to complete the above assignment successfully, we need to do the following tasks. So we will just go through the list of the tasks right now. We need to install and configure OpenStack Mitaka. This is not covered in this presentation. I will discuss later how you can access our cloud lab environment, which has already OpenStack Mitaka installed, and how you can use the lab environment to do all the tasks that we are going to do in this presentation. So we will continue, discuss our discussion. So we need to create a tenant, which is a project. We'll see how we can do that. We will create an admin and a regular user. So we will be creating users here. The third task will be to import an image to Glance. Glance is the OpenStack component responsible for managing images. We will create a flavor. As we will see later, a flavor represents a hardware configuration. Then we will do some network configuration. Our network configuration is comprised of 3 elements. The first one, we need to create an internal network for the tenant. This internal network is going to be used exclusively by the instances that we are going to create within a project. We will create a shared public network for all the tenants. We will see how we can do that. And then we will create a router and attach to it the subnet of the internal network first. Then we will attach to it the public network as a gateway, which will enable us to access the outside world, including the internet. Now we also need to create SSH key pairs for local user and add them to the instance. We will discuss why we need to do that. And then also we need to configure what is called a security group for the instance. As we will see later, a security group represents a tenant or project level firewall. So we will discuss that also. And then we will launch the instance. So all the preparation work that we did will help us or will enable us to create and launch an instance. And then to be able to access this instance, we need to associate with it a public IP address. And we will see also how we will be able to do that. And then we make sure that obviously that the DNS is working, the DNS of this particular instance is working. And then finally, with respect to storage, the storage of our instance will be a temporary storage. In other words, whatever data we store, it will just go away once we reboot our instance. So to be able to create a permanent storage, we're going to use Cinder. Which is the OpenStack component responsible of managing volumes and block storage. So we'll be using Cinder to create a volume and attach it to the instance. All right, so that's what we need to do. to be able to during this presentation. Now let's just talk a little bit about the required lab setup, and I have a slide here that explains this a little bit. So this presentation, for this presentation, I had to install Mitaka release on 3 nodes running. All of them, they are running CentOS 7. So I have a controller node, I have a network node, and the compute node. And if you would like, I can even show you in a moment, their configuration a little bit, specifically the network configuration. Now, this presentation assumed that OpenStack Mitaka RDO distribution has already been installed on these 3 nodes. In case you need to access our Cloud Lab environment to practice, please send me an email. You've got my email right there, ahmed@innosoftgulf.com. And or you can call our Dubai office, and you have the number for our office. So let's have a quick look at our 3 nodes. So here I have, this is my desktop, or the desktop. So I have actually the physical machine, which is called C Server 01. I have the controller nodes. I already have some stuff here. I'm just gonna get rid of it here. Okay, and then I have the network node, and then I have the compute node. So to just get a sense of what we are talking about here, let's have an idea here about what type of network configuration we have. So to do that, I'll just do IP address show and then say grep inet. So what we can see is that for the control node, which is on 2 different networks. One network is a public network, which is 192.168.1.0, and in this case, the IP address of our control node is 192.168.1.51 /24. And there is also a private network, which is 192.168.0.51 /24, which is going to be used for communication between the OpenStack nodes. And in my case, I have an OpenStack installation which has 3 nodes. It has the controller node, the network node, and the compute node. So you can do also the same thing here in the network, IP address, show, grep, inet. You will see that I have also in fact, with one thing we can notice here, that on the network node that I'm not using ETH1, but I'm using an external bridge. This is for neutral networking to work, okay? And then the compute node, the same thing. So the compute node, my first compute node is on 192.168.0.53, okay? And so all the nodes have 2 network cards. So just to summarize this networking part, or this network configuration part, ETH0 is configured so that the OpenStack nodes can communicate through a private network. And in this case, again, the private network is 192.168.0.0/24. ETH1 is configured to enable the nodes to communicate with our public network, which is in our case 192.168.1.0/24. The public network will provide us access, or all the nodes access to the outside world and the internet. Okay. So now, with this information, we can just move we can move ahead and try to do the demonstration. So here I'm going to get the dashboard. So to access my dashboard, I'm going to go to HTTPS controller. I already have that control, 51.innosoft.com, and then I'm going to type here dashboard. Okay, so the username, I'm going to log in with the username, which is in this case admin, and then the password is Innosoft. Now you might be asking the question, where did I get this information from? Well, once you complete your installation of OpenStack, if you go to the control node, and this is the root directory, or the directory for the user root, and then you can do a cat keystone rc_admin, which is the admin user, and you will find out that the username here is admin and the password is Innosoft. I know Innosoft is not a very secure password, but I'm just using it for demonstration purposes. So so I'm going to use these credentials to log in to my dashboard. So I'm connected here. Okay, great. So please note that the credentials of admin and the password Innosoft, they are for the system-wide administrator. We will see shortly how to create an administrator user per project or tenant. So let's go ahead. The first task that we will complete is to create a project. So here we have the projects. I'll just go ahead and say create a project. And then I'm just going to go ahead and call it project 1. Okay, and they say this is our first cloud project. And okay, at the moment we're not going to do anything related to the project members here or project groups, so I'm not going to change anything there. However, we will need to change the project quota, which defines essentially the resources that are available to a given tenant. So let's have a look at the quota. And we're going to just make some changes here in the CPUs that are available. Instead of 20, I'm just going to use 4 CPUs. In terms of the instances, I will be using 4 instances also. And in terms of the volume or injected files, I'll just leave the default values. And then for the RAM, you know, this is way more memory than what I really need. So I'm going to just make sure it's 1 gig, so 1024. And in terms of the security groups, I don't need to have 10 security groups. I might have just 4. And then in terms of the floating IP addresses also, I don't need 50. I'll just put 6. And the last variable I will change is the networks. I'll just make sure I just use 4 networks. And then I will say create project. Okay, so here we've got a project called project 1 that has just been created. So OpenStack would like us to create an administrator per tenant or per project. So let's go ahead and create an administrator for project 1. To do that, we will just go to users and say create a user. And let's call this user admin1. And this is the administrator for project 1. I don't need to put anything here with respect to the email of this particular user. However, I need to put a password. So for this, I'll just continue to use the Innosoft password because it's a password I can easily remember. And then here I will have to select the primary project, and then my primary project would be project 1, which I have just created. And the role that this user will play in this particular project, it will be as an administrator. And they say create user. So let's go ahead also and create a regular user. So to create a regular user, I'm going, so now I should be able to see, excuse me, I should be able to see the admin user which has been just created. Okay, so I'll just go ahead now and create a regular user. And then I will call this user 1. This is my first regular user. In terms of the password, again, I'm just going to type InnoSoft, this user. And then the project that this user will be has access to is project 1. And then here, notice in the role, I'm going to say that this user is just a member. So this user does not have any administrative privileges. It is important to know that we can administer our OpenStack cloud environment from the dashboard, as you have seen, or we can use the command line. The command line can be very helpful in troubleshooting problems that we might encounter while we are working on our OpenStack environment. So let's see how we can work a little bit with the command line. So I'm just going to go ahead and minimize this. So the first thing that we need to do is we need to create a configuration file for the tenant administrator, which we have just created. It's called admin1. And then this is how we will do it. So we have already a configuration file for the administrator for the whole OpenStack environment. So we'll just copy that. And then we will call this admin1. Let's go ahead and then make some changes to this file. So the first thing we need to change is obviously the username. In this case is admin. So we will make sure it says admin1. I will just leave the password, same thing. And then here I'm just going to make sure it says admin1. And in terms of the OS tenant name, this is the project name. In our case, it's not admin, but it's project 1. I'm just going to go ahead and save this. So to perform any administrative tasks related to our project, which is project 1, we need to source this particular file. So what we need to do now, if we want to do any administrative task, we need to do source keystone admin1. And now we have the proper permissions to be able to, to administer our OpenStack environment from the command line. For instance, what we can do is we can do something like this. We can do, if we want to see the list of all the users, we can do OpenStack user list. So that will provide us with a list of all the users that we have here. We can also, so let's write few commands. But before we do that, please keep in mind that moving forward, we are going to be using this admin1 user instead of using the OpenStack system-wide admin user, okay? So we only need to have administrative privileges for our particular project, which is project 1. So let's run a few more commands to see how this works. So if I want to have a list, an idea about the list of the projects that we have, we can do OpenStack project list. So we can see that now project 1 is listed. If I want to see what are the roles that we have, OpenStack role list. Okay. And then let's say, for instance, we want to create another user called user2 we want to create from the command line. So the way we can do this is OpenStack user create, and then here we can specify project. Excuse me, just 1 second. Project 1, and then here the password. Soft, and then we can say user2. Okay, so user2 has been created, and you can hopefully will be able to see that from the dashboard that the user has been created. But here again, I will log out as an administrator and log in as the tenant administrator, which is admin1. So if I go to users and then just use the filter and type something like user, you can see that I have a user2 has been created. And notice that it has been already assigned to project 1. Okay. So let's just look at our list of tasks that we need to do in this particular project and see if we are on target here. So far what we did is we created the tenants and users. So the next task is to import the Cyrus image to Glens. Okay, so let's do that. So Glens is the OpenStack component responsible for managing the images that we will be using. Yeah. So to be able to do this, please note that there is no need for us to be an administrator to import an image to Glens. So we can just do this as just user1. So I'm just going to log out and log in as user1 and put here soft, and then here I'm going to go to images, and then let's see how we can create an image. So now we will be using as I mentioned, a very small version of, this is a Linux distribution called Cyrus. It's primarily used for testing purposes, so I'm going to go ahead and do that. So let me go to the Google, and then I will just type here Cyrus, OpenStack, and then image. And then here I have, I'll go to this page, and I should see a list of images that are available for me to import to Glens. Going to select Cyrus. And then here what I'll do, instead of downloading it, I will just copy the link location. I will just say copy link location. Come here, and then here I'm going to specify what the link location is and just paste it. Okay. The other thing also that I need to do is I need to provide a name for my particular image. Okay. So let's call it very small Linux image 1, and then description, same thing. Okay, so here we specified the location where we are going to import the image from. Next, we will look at the format. For the format, we are going to use QCOW2. Okay. This is the format which is used for images prepared for cloud deployments. And I will just accept the other default values and say create image. Okay, it will take maybe 1 or 2 minutes to download and import the image to Glance. So now it looks like it downloaded the image and it's already imported. And notice the size of the image is really small. It's 12.7 meg. Okay. So this is good. Let us now find out how to create a flavor. This is the next task. A flavor is basically the hardware profile of our instance. So as a tenant member, a regular user can import an image to Glance but cannot create a flavor. So to be able to create a flavor, we need to log in as the tenant administrator. So let's just log out from here. And I'm gonna log in now as admin 1. And then I will pick the admin. Notice for the administrator user, he has this admin menu that's not available for regular users. And I'm going to select flavors. And I'm going to create. Notice that there are already predefined flavors. So you can use one of these flavors or you can create your own. In our case, let's just create our own flavor. I'll just call this one P1, mean project 1, my small underscore flavor. Okay. And then in terms of the CPUs, I'll say that this particular flavor will have 1 CPU. And then in terms of RAM, I would say it's 1 gig, but please note that it says here MB, so be careful about this. So I will say 1024, that will correspond to 1 GB. And then the root disk, I'm going to say it's 1 gig. The other values, I will just accept the default. Okay. So after creating the flavor, then our next important task would be to do the network configuration. So the first thing that we are going to do is to define an internal network that will separate the instances that we are creating from the physical networks that we have already been using. These physical networks that we have, if you remember, they are used by the control, the network, and compute nodes. They are just part of the networks we use in our OpenStack infrastructure. And this network, it should be separate from our physical networks. It needs to be different. It needs to be separate from any other networks that we are using, whether they are physical networks or whether they are networks used by other instances in other projects. So let's go ahead and create an internal network. So to do that, I will go to Project and then Network. And I will just go to Networks and say Create a Network. So here we will provide the name of the network is int net1. And then next, the subnet, we will call it int net1-sub. Okay. The network address will be 10.0.1.0/24. Remember, this is the address that I'm using to be consistent with the requirements that we have for this particular assignment. For the gateway, this is optional, but I just like to specify it. So let me put a value for the gateway, 10.0.1.254. Yeah, and in terms of the DHCP, yes, we do want to use the DHCP for our internal network. We will notice that for external networks, this is a little bit different. So, and then here we will specify the allocation pool, which is 10.0.1.100, comma 10.0.1.200. The other variables or fields, I will just we're not gonna do anything with them. So that's it. So here it says that the network, the internal network has been created. I always like to look at the network topology, and now we can see that we have here a network, and it is an active network. Okay. Now, just for a change, we need obviously to create an external network, but for a change, I like to do this from the command line. So let's see how we can create now an external network, and to do that from the command line. So let's do that. So here you go. It's going to be Neutron. Neutron is the OpenStack component that will enable us to manage networking or software-defined networks in OpenStack. And then here, notice the tenant ID is not going to be our tenant ID. It's going to be rather called services. And let's call this external network 1. And we can say router equal router external equal true. And then we will say this is a shared network. Okay. All right. Good. Now let's create a subnet and associate that with this particular network. To do that, we are going to do or run the following commands: Neutron subnet create. Okay. Tenant ID services, and it's going to be an external net 1, and the network is our external network is 192.168.1.0/24, and disable. Notice in this case we are disabling the HCP, and then I will explain this in a minute. And then here we will specify an allocation pool. And here the start of this pool would be 192.168.1.200. And then the end would be 192.168.1.210. Okay. All right, we've just then created the subnet and associated it with this particular external network. So again, for external networks, we need to disable the HCP, and we need to specify an allocation pool of IP addresses that are available in our network. You know, that's important, because in our external network, probably we have some IP addresses have already been used by some wireless devices or computers, and we want to make sure that whatever IP addresses we specify for our external network, they do not conflict with any IP addresses that we have already we are already using in our external network. So I like to just see right now what's happening with our network topology. So you can see right now that we have an external network right here, and it says it's active. So the third task, if you want, that we need to do with respect to networking or network configuration is to create a router so that both the internal and the external network can communicate with each other. So as you can see from our network topology, yes, we do have these two networks, but they are not communicating with each other. So let's go ahead and create a router. Again, I will just go ahead and create the router from the command line. I will just do neutron router create router 1. Okay. So the router has been created. Now, let's just look at a few things here. First, I like to be able to connect the subnet or the internal network with the router. I need to have a list of all the subnets. So I'm going to say neutron subnet list. Okay. So it will provide me the list of the subnets which we have just added. Yeah. So here is the subnet which is associated with the internal network, and then this is the subnet which is associated with the external network. Okay. So now let's attach the internal network to the router, and to be able to do that, let's run the following command: router interface add and to router 1, and what we want to do is add the internal subnet. I can also use the name, but I'll just use here, in this case, I will use the ID of the subnet. Okay, I like also to look at the network topology to see what happens here. Yeah, notice that a link has been already established here. And it says that there is an interface that has been added, and it has a status of active. Okay. Now let's attach the public network as a gateway to the router, and I'll do that also from the command line. So I'll do neutron router gateway. Set router 1, and then it's going to be the name of the external network, which is extnet 1. All right. So let's check again our topology and see that we have added it, and I'm also curious to see what's happening with the interfaces. So it says here active, and it says here build, active for the internal network, and then build for the external network. So that's good. So it looks like we have completed successfully our networking configuration. The next topic that we will be discussing is how to create the SSH keys. So I'll just look at the list again. What are the things that have been accomplished? We've already created tenants and users. We imported an image, or the Cyros image, to glance. We created a flavor. We did the network configuration, which includes creating a router, public and private networks. And then right now, this is where we are right now. So we need to assign the instance an SSH key and the security group. So this is going to be, we'll work a little bit on security right now. So let's do that. Now, I like to be able to access this instance that we are creating from my desktop environment. And my host name is called cserver01. So that's where I would like to be able to access the the instance from here. Let me just see if I do user del. I'm going to create a user. So this image comes that we've imported into Glance. It comes with a user called Cyrus. So I'm going to see if I'll just go ahead and create a local user called Cyrus. Oh, okay. Let me just go ahead and remove it. And I'll create it again. User del -r Cyrus, just for demonstration purposes. So normally what you do is you need to create a local user called Cyrus, and I will just also set a password for it, and they say that the password is called cabswin. So here I've already created this user and assigned it a password. So I'll just become the user Cyrus. And then I'll just go ahead and generate the SSH keys for this particular user on this particular server. And this is just regular Linux command that we are going to use, which is SSH key gen. And I'll just accept the default values. And the keys should be in the .ssh directory. So if I do ls-l, you can find that the keys there. I'm also curious to find out if they have the proper SE Linux context, and they do, which is ssh home_t. So this is the private key, and then this is the public key. Obviously, what we need to import into the instance or our OpenStack environment is the public key. So let's try to do that. So we are going to access and security. I'm going to look for key pairs, and we'll just create a pair. First, I would like to print the content of the public key. Let me just go ahead and copy that. So I don't want to create a key pair. I'm sorry. I need to import rather a key pair, which I will already have previously created. So let's call this key pair. We will call it cserver1 -Cyrus -key. Okay. And here I'm just going to put the content of the public key, and I'll say import the key. Good. So it looks like the key has been imported. Now, the next thing that we need to do with respect to security is to configure a security group. Again, security groups are, or the security group is the, for a tenant or a project, they are like tenant or project level firewalls that will enable us to implement security rules at the tenant level. Which, for instance, I can say for only this particular project, I like to enable SSH or enable access to the web server or enable ICMP pings, but for another project that may not be available. So let's see how we can create a security group and add some rules. okay, to allow three things, basically, to allow pings and to allow SSH and to allow the HTTP traffic. Okay, so to create a security group, I am just going to go to security groups here and say create a security group, and let's call it project1 underscore security group. So the description says this is project1 security group, and then go ahead and create it. Okay, good. Now, what we need to do right now is to add some rules to this particular security group. So let's say manage rules, and then here I will add a rule. So to enable ping requests coming in, I will do all ICMP. And notice the direction ingress. So ingress is basically the incoming traffic. And then this is for all the subnets. They will add that rule. Egress is for the outgoing traffic. So I will add another rule for SSH. Okay, and then I will add another rule, for instance, for HTTP, just for fun. Okay. Good. So here we are allowing pretty much, requests coming through all these different ports. Again, for this security group, the thing to remember is ingress, which means incoming traffic, and ingress, it's outgoing traffic. So it looks like we are ready right now to launch our instance. So let's see how we can do that. So I'm just so this basically will lead us to achieve the final goal or outcome, which is to create and launch an instance in OpenStack. So I will go to instances, and then I will just say launch instance, and then let's provide that with a name. We will call it Cloud Server 1. Okay, next. In terms of the images, I will choose the image that we have already added or imported to Glance. And then in terms of the flavor, I will make sure I use the flavor that I have created, the custom flavor that I've created, which is P1, my small flavor. Here we need to specify a network, and in this case we are going to specify the internal network. Please note that it's the internal network, not the external one. Later on we will see how we are going to use or allocate a floating IP address from the external network. For the security group, we will just assign it the security group that we've just added. And then for the SSH key pairs, we will just add the one that we've created earlier also. For the other screens, we'll just accept the default values. We're not going to do anything and say launch the instance. So it will take a few seconds to launch the instance, and let's have a look. So if I look at the console for the instance, it looks like it's up and running. Now, to be able to access the console, I always like to click this link here, So it says click here to show only console. So I'll click there. And then here I'm just going to log into the instance. The user ID again is, they provided us this right here. You can see Cyrus, the user, and then the password is Cubswin. Okay, so it looks like I am able to access the instance. I can do host name. It says cloud server 1, and I can do IPA to have an idea about the IP address of the instance. It's 10.0.1.101. That's good. Now, the instance is available. We can access it here, but we do also need to access it from from outside or from our public network. And to be able to do that, we need to assign it a floating IP address. So what I'll do is I'll just go ahead and see how I can assign a floating IP address to this instance. To do that, I'll just go here and click and say associate floating IP address. And then here I will click on plus to allocate an IP address from our external network, which is ext-net1. And we say allocate IP. And then, so this would be the floating IP address or public IP address that will be associated with this instance that we have just created, which has an internal IP address of 10.0.1.101. I'll just say associate. So, okay, that's good. So in this case, the instance has the IP address of 192, the public IP address 192.168.1.201. So I'll check if I can access it from my desktop. 192.168.1.201. Okay, it looks like I can ping the instance. That's good. Now, the other thing is that if you remember, we've created an SSH key for this particular user. So I should be able to also SSH to the instance. So I'll just go ahead and try to SSH as the user Cyrus. Okay, so it looks like I'm able to access the instance. I'll do host name here. And it says cloud server 1. Good. And then I can do ls blog, for instance, to find out like a little bit more information about the disk. I'll talk about this in a minute, okay? But so far, that's good. We are able to access the instance. We have a couple of things that are left to do, and we are done. So we need to create a Cinder volume and attach it to the instance from the command line. So just Cinder is the OpenStack component that will enable us to manage block storage. The storage that we have for this particular instance is a temporary or ephemeral. I'm having a little bit of hard time pronouncing this word, but it just means that once we reboot this particular instance, whatever data we store in it, it will be gone. And to sort or to resolve this issue, we need to assign or attach to this particular instance block storage. And we are going to do that from the command line. So let's go ahead and do that. So notice right now what we have is we have VGA and we have one partition, which is essentially the root partition here. So let's see how we can use Cinder to create a block storage and attach it to this particular instance. So to create a volume, we'll do Cinder create 1. So it will be 1 gig. And then the display name of this particular volume will be data_vol. So now we've just created the volume. You can also have a look at it using the dashboard. And so let's do now Cinder list that will provide us actually with the ID of the volume that we have just created, which called data volume, and the size is 1 gig. So to attach this volume to the instance, we can do something like this: Nova volume attach. We called it, I think it's called Cloud Server 1. And then we can specify the volume ID. So it says here, it looks like it has been attached. And to test whether it's actually has been attached, I'll do again ls block. And then you can see that we have a VDB disk that has been added right here. Now, just for testing purposes, we can create a partition, or let's go ahead and create a partition of 100 meg on this second disk that we've just attached to our virtual machine. So again, I'm here in the instance itself. So let's go ahead and do something like this. We will just do fdisk dev as vdb. Okay. Yeah, I'm sorry, we can do that as regular users. So I'm just going to become root right now and do fdisk dev vdb. And then here to print, do I have any partitions? It doesn't look like I have any partitions here. And I will just go ahead and create a partition, and it's going to be a primary partition. Partition number, the default is the first one. I'll just select the default value for the first sector. And then for the last sector, I will just say 100 meg, okay? And say p to print, and then we've just created a partition. And if I'm happy with that, I can just write these changes to the partition table. Okay, now what we can do is we can, let's go ahead and format the partition with the file system. So we'll do makefs -t ext4 dev vdb1, which is the partition we have just created. Okay. And what we can do is we can mount the partition. So I can do mount dev vdb1 to mnt. And I can do echo hello from Dubai to send it to mnt greetings, something like that. And then if I do cat mnt greetings, that should say hello from Dubai. Okay, so if we are happy with that, let's just go ahead and then unmount the partition, the mnt. So one final thing that I like to do with respect to this presentation is to be able to see if we can access the outside world from this instance that we have just created. So if I do ping www.google.com, it says it doesn't know what that is. So if I look at my DNS configuration, notice that it doesn't have a name server that can resolve something called www.google.com. So let's take care of that. So I'm just going to do something like this: echo name server 8.8.8.8. So I'm going to add that to etc resolve.conf. And now if I do ping the Google Yeah, now I'm able to ping Google. Okay. Great. So basically, that will conclude my presentation. Again, if you need to, if you need to access our lab environment to do or perform all the tasks that we looked at, just please feel free to send me an email or call our office in Dubai. So let's just have a quick summary here of the tasks that we have completed. So we did, OpenStack was already installed, so we didn't do any installation of OpenStack. However, we created a tenant, we created users, we imported an image or small image to glance. We created a flavor, and we did some network configuration where we created a router, we created a public network, a private network. Then what we did is we worked a little bit on security, where we created SSH keys for a local user and imported the public key of that user to our instance. We also configured a security group for our tenant, and then we added few rules that enabled us to allow SSH and allow the HTTP traffic and also ping requests. And then we created the instance and assigned it an IP address, and we were able to access. We created the instance, we assigned it a floating IP address, and that enabled us to access the instance from our public network. Finally, we added a block storage to our instance, and also we made sure that the DNS is properly configured. So that's all I wanted to show today during this presentation. So I just want to thank you for your patience with me. Now, I know that some of you probably already want to know a little bit about who we are, so I just prepared a few slides. I promise I'm not going to take too much of your time to just explain who we are as a company. So InnoSoft is a leading-edge IT education center in the Middle East and North Africa, and we provide OpenStack lab infrastructure as a service. So if you need a lab environment for testing, and working with OpenStack, we'll be happy to provide you with such infrastructure. We also provide leading-edge OpenStack training. We delivered OpenStack training to some of the largest organizations in this region, including Motorola Solutions and Wipro and some other large organizations. And we can also provide assistance in terms of the architecture and deployment of private clouds using OpenStack. And I just added a slide here that will show a little bit where we are located. So we have an office in Dubai Knowledge Village, or rather it's called now Dubai Knowledge Park, Block 11, office G03. And then also we have a really very nice office in Kazanier Shore Park in Casablanca, Morocco. For more information, please feel free to contact us. And you can see here our office number, even my mobile. I have decided to put my mobile because in my previous video, some people have asked for my personal contact details. So you can see here both my mobile and my personal email. That's it. So thank you for watching this video, and I hope to see you again. Bye-bye.